Let's have a quick conversation about the cyclic integral. We'll start off with an example about a pressure volume graph right here. When we try to take the integral of pressure as it changes with respect to volume, we're able to get work, which will give us units of Newton meters, as in like your force times distance. We're able to get there because our pressure we can assume is in, say, pascals, and we're multiplying that against our differential of volume. And when we break this down and we just look at how the dimensional analysis carries through, we have a Newton per meter squared times our meter cubed. And if we take a little closer look at that, we can say, yes, we will have newtons times meters. So that means when we are taking the integral under this curve from 1 to 2, we're able to find work. Now let's take that one step forward and we'll look at our Carnot cycle when we covered this in week 2. In the Carnot cycle, we start at point 1, we move to point 2 by adding heat, and we go from point 3 over to point 4 by pulling heat out of the system. When we were in class, we talked a little bit about how W is going to be equal to this cyclic integral. And we get to this point by integrating around the curve or around the cycle. So what I'm going to show you is that this is essentially the same as saying we're going to go from 1 to 2, from 2 to 3, from 3 to 4, and then 4 to 1. So if we take all of these integrals here, you'll start to see that if we are going from 1 to 2, we'll take that positive area under the curve, and then we're going to add in this area here, or this is a 2 to 3, and then we're going to add in going from 3 to 4. This is technically going to be a negative area because we are going from right to left. So you can imagine we would just have a little -1 right here. And when we do that, we'll have this line here. We could take this area under the curve, and then we'll just do our, plus -1, that line right there, and there's our 1 and 4. We're taking that area under the curve there. Now, when we add all of these up, what we're essentially doing in our figure is we are looking at the area inside our Carnot cycle, because we're adding this, subtracting that, and subtracting that, which means we technically had these areas here in between these lines, and we subtracted them away. So when you see this cyclic integral here, all it's saying is that we are technically taking 4 integrals for a cycle, or however many points it takes to go through this cycle, and we're just going to summarize it with that little bow tie right there.